Hello everyone, I'm really excited to be here to present our paper from Plane Clashes to Algorithmic Harm, Applicability of Safety Engineering Frameworks for Responsible ML. In this paper, we had two main research questions. The first question is, how are ML practitioners currently identifying and assessing social and ethical risks, and what are the existing challenges that they face? The second question is, what are ML practitioners' perspective towards using safety engineering frameworks for social and ethical risk management, and how could they use these types of frameworks to improve responsible ML practices? When it comes to anticipating harms of ML systems, there has been two main categories of approaches for machine learning systems. One has been looking at critical epistemological perspectives, such as critical theory and feminist HCI, to understand what users and values should we pay more attention to when it comes to evaluating ML systems. And then the second category has been design methodologies, such as value-sensitive design, participatory methods, which could be used to understand how we can design ML systems to integrate in a more meaningful way within our social systems. There's also been a series of toolkits and frameworks developed by industry and practitioners to provide external oversight for responsible development and also to provide self-regulation as well. Some scholars in the responsible ML community have hinted at potential use of safety engineering frameworks for assessing and mitigating potential risks, potential social and ethical risk, and establishing traceability and accountability practices. The two frameworks that have been discussed primarily for application for ML systems are FMEA and STPA. These two frameworks are some of the most successful and widely used frameworks across safety-critical industries. FMEA and STPA are not the only frameworks that exist. As you can see, there are a number of other safety engineering frameworks that have been developed from 1940s to 2020. However, these are the frameworks that have been discussed for ML systems, and these are the ones that we will be talking about and mostly focusing at in our study. FMEA takes an analytic reduction approach for safety analysis and tries to identify potential failures by breaking down a system into smaller components and seeing how each component can fail. On the other hand, system theoretic process analysis takes a system theoretic approach and really tries to identify the losses that we are trying to minimize for in our overall systems and looks at the different interactions within our systems and sees which one of these interactions could lead to these losses, and develop safety requirements to really improve these interactions and making the overall system safer. For our study, we conducted semi-structured interviews with experts and we recruited our participants that worked in the industry for at least a year and had been tasked by assessing and mitigating social and ethical risk for ML systems. We recruited 30 participants that covered 4 different roles of researcher, analyst, manager, and engineer across 6 different companies. In our interviews, we asked the participants about their roles and expertise. We then followed to ask them about current practices when it comes to defining, assessing, and mitigating social and ethical risks. We then introduced FMEA and STPA using an example and then gathered feedback on each one of them separately. And then we asked the participants about the initial impressions of FMEA and STPA, and we also asked them to walk through how they would apply a process like this to a machine learning project that they had worked on in the past. We conducted reflexive thematic analysis where we coded the data with the co-authors of this paper, and they met a number of times to discuss what are the emerging themes from this work. Some of our key findings for our first questions revolve around the definitions, evaluations, mitigations, and challenges when it comes to identifying and assessing social and ethical risks. When it comes to definitions, there was 3 primary ways that our participants defined social and ethical risks. They stated that social and ethical risks exist when there is a harms to users, or when there's transgression of AI ethics principles, or when there's a violation of human rights. Overall, there was a lack of standard definition, and this was something that was frustrating to an extent to our participants because it created inefficiencies and also inaccuracies in the works that they were doing. When it came to evaluation, the participants primarily used 3 different approaches to evaluate for social and ethical risks. They either qualitatively mapped potential harms of an ML system to different stakeholders, or they quantitatively assessed the ML system's properties such as fairness, or they interrogated product and research development processes to see how processes could be improved to make safer systems. Overall, there was a great need for multidisciplinary collaboration to do a good evaluations, and the types of evaluations really work ad hoc and dependent on what product was being analyzed and who was put on the task. When it came to mitigation, it required a significant amount of cross-functional partnership across product teams and necessary expertise, and experts leaned towards solutions that fit under their capabilities and knowledge, and there was no clear guidelines on which mitigations there need to happen and which mitigations are not necessary. And finally, decisions to mitigate were really dependent on the amount of resources that was there, and those were done on very much ad hoc basis as well. When it comes to conducting these assessments, participants noted a few different challenges. One is that there was a significant amount of organizational challenges and a significant, and in terms of what was the incentive structure for different participants to do this type of work, and they also faced a lot of resource constraints, especially when it came to getting access to diverse perspectives. There was a lot of issues in terms of bringing in the right people at the right moment, especially because it was very hard and resource intensive to do so. And finally, there was a lot of challenges with evaluating ML systems, which are often quite complex and not transparent for many of the people that were tasked by for analyzing these systems. And also that there's a lot of novelty with analyzing these systems, as there's not a lot of knowledge about how they could fail. When it came to our participants' perspective towards safety engineering frameworks, they overall mentioned that STPA and FMEA-like processes provide sound structure, and that they could really see themselves using these types of processes in some of the analysis that they were doing. They also mentioned specific perspectives towards each one of these systems. So when it comes to, for example, FMEA for ML systems, they mentioned that an ML system could be broken down based on the intended function or the use of it, or it could be broken down based on the different stages of the development pipeline. They were able to walk through and identify different ways of applying FMEA, and they mentioned that some of the existing practices were similar to the FMEA process. They really wanted clarification on effect on who when we're identifying effects for the failure mode, and they mentioned that there needs to be different stakeholders that are considered, and effects will be different based on different stakeholders. And they mentioned that identifying control can be really beneficial for streamlining mitigations and evaluations. And finally, they noted that there's a lot of challenges when it comes to identifying effect, cause, and control and scoring them, because there's a lot of knowledge gaps and uncertainty. When it came to STPA, they mentioned that ML systems can be we can identify the stakeholders for ML systems, and when it comes to identifying the purpose analysis and identifying the losses, starting from losses, it was quite intuitive for them because this was user-oriented, and this is something that many of them already did. They mentioned that when it comes to identifying the control structure and creating control structure, they could use internal company processes to be able to create control structures, or they could look at human ML interactions. When it came to identifying the unsafe control actions, they mentioned that unsafe control actions can be mapped to design choices or decisions. And there's no major themes about identifying loss scenarios because we don't really have too much time to discuss that. And one of the things that the participant mentioned is that understanding context is really critical for social and ethical risk management, and FMEA and STPA have their own limitations. FMEA can be agnostic for the socio-technical context, and then the system theoretic process analysis can really abstract away the social phenomenon as we're choosing proxies as we are modeling the system. Also, implementation of FMEA and STPA-like processes require significant amount of organizational shift and internal capacity building. As one of the participants mentioned, is that the current engineering culture is not necessarily built or set up to be able to take in these processes very easily. So when it comes to adapting safety engineering framework for responsible ML, the key takeaway is that the safety engineering frameworks could provide a well-defined and structured framework for responsible ML development. However, there's going to be some need to really address some of the challenges that we have already identified. The structure that they provide can be a communicative tool between different stakeholders and experts that are tasked by conducting this assessment, and also it's a method of establishing accountability for upcoming policies and regulations. There are some challenges, as we have mentioned. It's very important that we take these as opportunities for improving these systems. And thank you so much for taking the time to listen to this presentation. I'm looking forward to